And this question is given that a point source of heat of power P is placed at the center of a spherical shell of mean radius R. The material of the shell has a thermal conductivity K. The temperature difference between the outer and the inner surface of shell is not exceed T. The thickness of shell should not be less than. So let's try to understand this question. So over here we are considering a point source of heat power P is placed at the center of a spherical shell. So we can just consider a spherical shell, something like this. And a point source is placed at the center. So just assume that this is our point source, which is continuously emitting some thermal radiation. So this is our point source, which is shown in a red color. And the power of this arrangement is given. Let's say that is equal to P. So it is emitting radiations in each and every possible directions. So these heat radiations or the heat energy is passing through the side walls of conductor. The material of shell has a thermal conductivity K. So the material of conductor means we are talking about the part of this conductor. So this is basically having some thermal conductivity. So let's say the thermal conductivity of this part is represented by nothing but K. The temperature difference between the outer and inner surface of shell should not exceed delta T. That means temperature difference across this one should not be greater than, let's say this delta T cannot be greater than T. The thickness of shell should not be less than. So Rm is to find out what about the thickness of the shell. Rm is to find out the value of T. So we can use this equation dq divided by dt, rate of flow of heat energy, is equal to Ka delta T divided by L. And over here this L is representing the length of conductor. Over here it is like the thickness of shell. So Rm is to find out the value of L. So we can write this as Ka delta T divided by dq divided by dt. So we can write this as K into area. Area we can take it as its surface or its cross-sectional area. We can write that is equal to 4 pi r square. So area we can take it as something but 4 pi r square. And difference in temperature across the shell we can take it as something but T. It is given in question. Divided by dq by dt is something but the rate at which heat transfer is taking place, which is nothing but the power of the source P. So I'll get the value of L as equal to nothing but K into 4 pi r square. According to this question, radius is given as capital letter A. So we can write as K into 4 pi into capital letter R square into T divided by the power P.